Okay guys, continuing with page 28, there was one thing I forgot to mention about trapezoidal and rectangular approximations, and that would be when you have an over and when you have an underestimate. It's easy enough for me to just draw a picture. If you have a curve like this, you just break it into one giant section. If we did a trapezoid, the trapezoid would be an over approximation because we're concave up. And then obviously reverse if we were concave down. For this same picture, if we did a left rectangular approximation, that's going to be an under approximation. Because f of x is increasing. And if we did a right, right would be an over approximation because f of x is decreasing. And then the reverse would be true, obviously. If I gave a decreasing function, I meant to say increasing here. Okay, so moving on to example 1 here is integral as an accumulator. This is a classic fundamental theorem problem, but from a picture. If we have one x value looking for the y value at the other, then integral of f prime of x from 0 to 1 equals, as per fundamental theorem, f of 1 minus f of 0. So then if we have f of 0, we do f of 0 plus integral from 0 to 1 of f prime of x dx equals f of 1. Now sometimes you could find an equation for f prime of x, as you could here, but really it's just a shape, so just do your area. Area of that triangle is 2. So then 5 plus 2 gives me f of 1. In other words, f of 1 is 7. Here's some examples underneath of here. You can obviously do them as needed. Example 3 would be a calculator problem. Integral of a of t from, when I look at my x values, 2 to 5, gives me v of 5 minus v of 2 as per fundamental theorem. And this actually would be a calculator type problem. So we're looking for v of 5. v of 5 would be equal to v of 2 plus the integral from 2 to 5 of a of t. This would not be a problem that you can do by hand. This would be a calculator question. And of course, you can check that off of our Calc Bible answer key, but that would be all thrown in the calculator. So from pictures, some things you could do when you have a graph is you could approximate your slopes at different values. If we want f prime from a graph of f, then we would look up here and just do a slope problem on this piece. That would be up 3 and over 2. Values like that. Ones to be careful of would be at any of these places where we have a sharp turn in the graph. Those places would be undefined, all of those. And any other one you could just calculate the slope. Then if you were looking for an integral, that's going to be just all of your areas added up here, but of course counting this one as a negative 2. So then it would be adding up all of these values here, but making sure that that one that was underneath you count as a negative. And you can break it up in any slices that you want. Okay, the difference is here, when you do this kind of problem, you would count that 2 down here as a positive. All of those would this time be positive when you have that. Other thing to be careful of, if you had a problem like this, I would break this one up I would do that area calculation where I count the below parts as negative, but then I would just add to that integral from 0 to 10 of 5 dx, which this part right here would just be 50. So the careful thing you want to make sure you do here is not just add 5 to that integral value, but actually add 50. And then for any of these other ones, if you have the values seemingly in reverse order, I would just then get the opposite value.